hydrogen cyanide, which is colorless liquid below 25.6 degrees Celsius, and this is colorless gas above 25.6 degrees Celsius. When this hydrogen cyanide is dissolved in water, that is aqueous solution of hydrogen cyanide is known as hydrocyanic acid. Hydrocyanic acid, which is also called prussic acid. Hydrocyanic acid. In this lesson, we are going to learn addition of hydrocyanic acid to carbonyl compounds. So let us begin. Addition of hydrocyanic acid to carbonyl compounds. Let's see the matter. Carbonyl compounds. This is functional group of carbonyl compounds. This carbonyl group gets polarized in this way. Pi bonded electrons move towards oxygen because electronegativity of oxygen is 3.5, but electronegativity of carbon is 2.5. That is why pi bonded electrons move towards oxygen. When carbonyl compounds are added to hydrocyanic acid, that produces proton and cyanide ion. Here, cyanide ion is a kind of nucleophile. Carbonyl group gets polarized. Oxygen becomes negatively charged. Carbon becomes positive in charge. And nucleophile from hydrogen cyanide combines with positively charged carbon first, and after that hydrogen ion, this cation, combines with negatively charged oxygen. Here nucleophile combines first positively charged carbon. That is why it is said that carbonyl compounds give nucleophilic addition reaction, not electrophilic addition reaction. Here electrophile combines with oxygen, nucleophile combines with carbon. Nevertheless, it is said nucleophilic addition reaction because oxygen is a highly electronegative atom. That is why oxygen doesn't give electrons to the electrophile firstly. That is why nucleophile combines first to the positively charged carbon first, and then electrophile combines with negatively charged oxygen. For this reason, for the reason of high electronegative atom oxygen, it is said carbonyl compounds give nucleophilic addition reaction. Let us see additive product. Cyanide ion combines with positively charged carbon. Then proton combines with negatively charged oxygen. This is additive product which is called cyanohydrin. What is the importance of the reaction? When the cyanohydrin is hydrolyzed, then the cyano group converts to carboxyl group, that is carboxylic acid is prepared from cyanohydrin. This is the importance of the reaction. Let us see addition of hydrogen cyanide to carbonyl compounds. Carbonyl compound. Ethanol or acetaldehyde. Hydrocyanic acid that produces proton and cyanide ion. Cyanide ion combines with positively charged carbon and proton combines with negatively charged oxygen. As a result, this compound is formed. Ethanol cyanohydrin. Again, this is propanone or dimethyl ketone. Hydrocyanic acid that produces proton and cyanide ion. Cyanide ion combines with positively charged carbon. Proton combines with negatively charged oxygen. As a result, this is obtained. Propanone cyanohydrin. Again, benzaldehyde, hydrocyanic acid, cyanide ion combines with carbon, which is positive in charge. Proton combines with oxygen, which is negative in charge. As a result, this compound is formed. Benzaldehyde cyanohydrin. Let us see another reaction. Now, the reaction is with benzophenone or diphenyl ketone, hydrocyanic acid that produces proton and cyanide ion. Here, cyanide ion is supposed to combine with positively charged carbon and proton is supposed to combine with negatively charged oxygen. But in this case, actually, no reaction occurs because here two phenyl groups of large size create steric hindrance. Because of the steric hindrance by two phenyl groups of large size, nucleophile cannot attack the positively charged carbon. That is why no reaction takes place. This is called steric hindrance or spatial hindrance. Because of the steric hindrance or spatial hindrance, benzophenone or diphenyl ketone cannot give additive product with hydrocyanic acid. Let's move on to the next point. Uses of cyanohydrin. cyanohydrin, suppose this compound. In this compound, this group, cyano group or nitrile group, contains carbon. That is, functional group contains carbon. So this is carbon number 1, this is 2, this is 3. This compound is 2-hydroxy 2-methyl propanenitrile. When this is hydrolyzed in presence of acid and refluxed. Refluxing is a system that makes the reaction happen. Here, when this compound is hydrolyzed and refluxed, then cyano group converts to carboxyl group. That is, cyanohydrin is converted to carboxylic acid. This is the importance of this reaction to produce carboxylic acid. Here, functional group carbon is numbered by 1, 2, 3. This is 2-hydroxy 2-methyl propanoic acid. 2-hydroxy 2-methyl propanoic acid. Just a single word. 2-methyl 2-hydroxy propanoic acid. This is all about addition of hydrocyanic acid to carbonyl compounds. No more today. Thank you very much.